Now let's look at naming oxyacids. And the way we're going to name oxyacids is pay attention to the polyatomic ion that the oxyacid is based on. If the polyatomic ion name ends in 8, then the oxyacid turns the 8 to an ic. If the polyatomic ion names ends in ite, then the ite goes to us, O-U-S, and the word acid is at the end of all names. So let's see if we can name these two acids. First, we look at the second part, not the hydrogens, the second part of the acid, the non-hydrogen part, and identify the polyatomic ion. SO4 is sulfate. Sulfate. And SO3 is sulfite. Now, one thing I want to point out is whatever charge you have on your polyatomic, that is how many hydrogens you're going to have. But anyway, let's get back to naming this. According to our rules, 8 goes to ic, and ite goes to us. So let's look at the name. This is going to be sulfuric. The 8 went to ic, and then we add it with acid, ends in acid, sulfuric acid, H2SO4. H2SO3 is going to be sulfurous. The ite went to us, acid. So let's apply the rules that we've just gone over for naming binary acids and oxyacids and see if you can name each one of these. Okay, so let's look at our first acid here, and we know these are acids. They all begin with hydrogens. This is a binary acid. It has two elements, hydrogen and another element. So binaries always begin with hydro. They have the root name and they end in ic. So hydrosulfuric acid is the name of this. Next, we have an oxyacid. And the first thing we have to do is to identify our polyatomic ion, which is chlorate. Let's write up here, this is an oxyacid. And we have to remember our rules that 8 goes to ic. So this is going to be chloric acid. Now let's look at our last example, HNO2. And this is another oxyacid. So we identify our polyatomic ion. This is nitrite. And we remember our rule that ite goes to us. Sorry, I gotta read that. Goes to us. So this is going to be nitrous acid. So if you got these right, give yourself a big pat on the back. Now let's look at working backwards, finding the formula from the name. So what we're going to do is we're going to use our conversion here between us and ite and figure out what the polyatomic ion is that this acid is based on. So if it's chlorous, that means that it's based on chlorite. So chlorite is ClO2-. Now to get the acid from this, we look at our charge, and whatever our charge is, that's how many hydrogens we have, and our hydrogen always comes first. So I have a -1 charge, so that means I have 1 hydrogen. So this is the formula for chlorous acid. Now let's take a look at phosphoric acid. And phosphoric goes back and forth with 8, and I remember this because I think of I ate something icky. So ick and 8 are related. So phosphate is the polyatomic ion that this acid is based on. And phosphate has a formula of PO43-. The charge tells us how many hydrogens we have, and there's our formula for phosphoric acid. Now let's look at hydrobromic acid. The hydro tells me it is a binary, so I only have one other element, and it's bromine. Now, how do I know what the ratio of hydrogen to bromine is? Well, we've got to go back to the ion that bromine forms. Because it's a halogen, in one column away from the noble gases, it always forms a -1. And just like the polyatomic ions, we have as many hydrogens as our charge, so the negative charge on our anion. So since it's -1, we have 1 hydrogen. So pause the slide and see if you can figure out the formula for carbonic acid. Okay, so we remember ic means 8. So this acid is based on carbonate. And carbonate has a formula of CO3 2-. Now we know how many hydrogens we should have, 2. So H2CO3 is the formula. If you got it, give yourself a high five. So let's sum up what we've learned about naming, also known as nomenclature. So you may hear this term in other courses, so I just want you to be familiar with it. Nomenclature simply means naming. We'll look at acids in the next slide, but the first thing you want to do when you look at a compound is figure out whether it's ionic, molecular, or an acid. If it is ionic, then there are a few possibilities. Okay, I don't know why I just said there are a few possibilities. If it is ionic, then you follow the simple rule of the cation name and the anion name. Now, to tell whether it's ionic, if you see a metal in a compound, it is automatically ionic. The only tricky part is if ammonium, NH4, is the cation. So anything that begins with a metal, any compound that begins with a metal, or any compound that begins with NH4 is ionic. The metal, or the NH4, is the cation part, and then the nonmetal, or most polyatomic ions are anions, are going to be the anion part. And as I said, you merely state the cation name and then the anion name. The only time you have to use a little bit of math, well, I guess a little bit more math, is when you're dealing with the type 2 metals. You need to show a Roman numeral to show their charge, because these type 2 metals have variable charges, and whatever charge they have will have a big impact on the formula. So you must show their charge as a Roman numeral if they are type 2 metals. Also, we want to remember, if we have more than one polyatomic in a formula, we use parentheses. So those are the key features of naming with ionic. For molecular, these are non-metals only, and we're only going to be looking at binary molecular, 2 elements only. The Greek prefixes give the subscripts, and we don't use mono for the first element if there's only one of it. And to name the molecular, the first element in the formula retains its elemental name, and the second one is the root with "ide." And then here are acids, and we have the binary acids, which are going to be hydro, and then the root, and then end in ic acid, and then we have the oxyacids, which are going to be based on polyatomic ions. And what we do is ic and 8 are the relationship between the polyatomic ion and the acids, 8 in the polyatomic ion, ic in the acid, and then us and ite. And like the binary assets, the name ends in asset.